So I'll directly go to the demo because yeah, almost out of time. So I'll first start by showing you the Azure portal. So this is the so when you open Azure account, you get access to the Azure portal, and then from there you can manage whatever the compute resources, storage resources you can deploy in the Azure cloud. So you can create hosted services where you can deploy your worker roles, web roles, or VM roles, and as well as you can also create storage services where you can store your data, and then also configure the other services like the database service, the service bus access control, etc. So currently I have deployed a simple application with 6 instances. So it has 5 worker roles as well as 1 web role. So if you go to the Visual Studio with the Server Explorer, you can add your service as well as storage accounts to Visual Studio, and then you can have a look at them from your Visual Studio as well. So in here I have my Azure service configured in Visual Studio where it shows the instances running, as well as one of my storage accounts. So this is the blob storage, and then I have a container called 10K input. So it stores these blobs inside that container. And then this is a view of the Azure tables. So there are a lot of third-party tools as well which you can use to access data stored in Azure storage as well as to manipulate data stored in Azure storage. So let's have a look at how we implemented the K-means clustering with Twist of Azure. So if you're using Twist of Azure to implement K-means clustering, you just have to implement your map task where you will get your data in the form of a vector array, and then you just do the cluster assignment computation in the mapper, which should be like this, and then you can write a reducer where you would do the cluster recalculation step, and then we have the merge step where whatever the new clusters generated by the reducers would be collected, and then it would decide whether to go for a new iteration or not based on the clusters we have for this iteration and comparing them with the clusters we have for the early iteration. And then here we decide whether to go for the next iteration, and then the data would be broadcasted to the next iteration. So we also need to have a driver task which should configure the computation. And then, so if you're using Twist of Azure, you just need to implement those. You will get all the others through the framework, and Twist of Azure will also create like worker roles for the computation, and then also have a web role to deploy the monitoring interface. So this is the so in here now I'm looking at a web role, an Azure web role. So you can configure it here. I mean, you can specify the number of instances you need, the instance size, and then you can add any application specific settings here, and then configure a local or outside endpoint. You can do all these configurations, and you can configure your storage accounts you need to associate with this service, etc. And so now let's have a look at the worker role. So the configuration API is more or less similar, and you can do all those configurations in here. So these are the features provided by the Windows Azure SDK, which we use to configure the Twist of Azure. And the deployment with the Azure cloud is very simple. You can have your Azure account. You can sign up for Azure account, and then you can configure it with your Visual Studio. Then when you have that done, you can just right click and then use publish, and then you can directly publish to the Windows Azure. And then so we have mentioned the number of instances we need and all the configurations in our configuration step. So when you deploy it from here, it will get deployed to the Azure cloud, and whatever the number of instances would be deployed, and then your application would be up and running. So as you can see, deploying an application to Azure cloud is much easier than deploying something to a infrastructure as a service cloud. So I'm not going to deploy it now because I already have the application deployed. So this also supports other features like enabling remote desktop for your roles, where you can log into the nodes and see what's going on. Yeah, so things like that. And then advanced settings, like if you want to do profiling, you can do them. So, so another feature I forgot to mention is if you run this application in the Visual Studio itself, it's going to deploy into a local development environment where the application will run, and then you can debug your computation and you can test and do anything you need. And then in here, when you configure your storage resources, you can also select to use the Azure storage emulator. So even the storage would be using your local development emulator. Yep. And then another way to upload, deploy a Azure application is to create a package here. And so when you do this packaging, Azure will bundle up your deployment package. So we had an earlier question how to create virtual images for Azure. So other than creating virtual images, we just create these Azure deployment packages for your web roles and worker roles. And then you can upload that package through the Windows Azure portal, where you can, when you have a service created, you can just go to new production deployment and then browse your package and the configuration file generated, and then the service will get deployed. So now currently I have this K-means clustering application running on Azure. So let's just have a quick look at it. So now we are going to the web role of that application, which acts as the monitoring UI. So I have early execution of this application where I was using 5 million data points and then 5 Azure instances to run it. So we can have a look at the execution trace of that computation. So you can see here, like this is the first iteration, which is taking much longer, and then the subsequent iterations are taking less time, and then the computation is executing. So we have performed these kind of computations up to 256 instances at the moment, and up to 256, we have seen twist of Azure is scaling really well without any communication or that kind of issues. So now I'm going to submit a simple computation, which should be using a very small amount of data, because if we submit the 5 million computation, it will take more than 10 minutes to finish. So I'm going to just use 10,000 data points and then do a sample computation. So this should run much faster. And now the web role will submit the task to the Azure queue, and then they'll get scheduled to the workers. So it's done. So the first iteration got scheduled through the queue, and then the data was originally fetched. That's why it's taking much longer. And then the subsequent iterations were executed using the caching and the cache-aware scheduling, so they executed much faster. I mean, we have these occasional high compute, occasional tasks which took much longer time. I mean, that's because this data set is very small. So, yep. So, yeah, that's it for this presentation. So I would like to thank Microsoft Extreme Computing Group for providing us with the Azure grants, and then the Persistent Systems for providing us with funding, and then, of course, to the IU Salsa Group, which implemented these frameworks. Thanks.